With manual summarization, you can manually summarize detailed routes. And you can freely scheduling the scope. Let me stop WeChat for a moment. They are happily chatting there. We won't listen anymore. I'll sneak a peek after class. And we can also automatically schedule such a range of summarization. Which detailed routes we summarize, and also be able to use route leaking. Leaking. This is a huge benefit brought by our manual summarization. So suppose, we now encounter manual summarization. The difference between manual and automatic summarization comes here. Still the same as the first diagram above. So if at this moment we have these routing entries, we have these 6 detailed routes, then we want to summarize outward. Our summarization route can integrate them. Let our R1 encounter fewer detailed routes anyway. The next hop is all R2. We try to reduce R1's routing entries. How to do this? We can find commonalities. How to find commonalities? We once learned ACLs in NA. Regarding ACLs at that time, we said it could be used to match routing entry prefixes with wildcard masks, our access control lists, to match multiple entries at once. Here, if we want to summarize all these 6 detailed routes, we can find their commonalities, list them as binary numbers. First 2.2.2.1 0000010 0000010 0000010 This is our 2.2.2.1. I'll call it down. Then 10, 11, 100, 101, 1, 2, 3, 4, 5, and another 6. 110. So we want to summarize all these 6 detailed routes. We once talked about ACL, we need to use a statement, prefix plus wildcard match multiple routing entries. So we use the prefix notation, what's it called? Common test questions, old test questions, different as 0. We can find the common prefix of all 6 detailed routes. How much? Same. 0, 0, 0, 0, 0, 0, 0, 0, 0, same. Just copy. 0, 0, 0, 0, 0, 0, 1, 0, 0, 0, 0, 0, 0, 0, 1, 0, 0, 0, 0, 0, 0, 0, 1, 0, copy. 0, 0, 0, 0, 0, different as 0. Proof starts. 0, 0, 0, 0, 1, 1, 1, 0. Everything in front is the same. Same, right? The back is different. Students, 0, 0, 0, 0, 1, 0, 1, 1, 0, 1, 0, 1, 0. The different becomes 0 using this method. We can write out our common prefix 192.168, oops, 2.2.2.0. This is our common prefix. So what is our mask after summarization? What is the same after we've summarized? Look here, look at our common parts. The rest are variable. They are the parts that will change. The first 29 bits are the ones that do not change. We have found the common prefix for 6 detailed routes, and their common network part. The common network bits, minus 29, this is the commonality of our 6 detailed routes. Found a 2.2, 2.0-29, the same summary route entry, 2.2.2.0. 29. What is summarization? When I announce detailed routes, as long as they can be matched by summarization, we only announce the summary route. Only announce the summary route, integrating these 6 detailed routes into one. A summary route that covers all our 6 detailed routes. This is our summary route, so this is our manual summarization. Now, R2, we announce so many detailed routes, all integrated into a 2.2.2.0, 29 summary route, like a single R2. Right, brothers? So we must remember, whether it's a main class, whether it's our automatic summarization or our manual summarization, they actually have a very clear characteristic. Whether automatic or manual, what's it called? Suppressing detailed routes, so only announce the summary route. This is a very clear condition of our summarization. If we are going to summarize, when we announce routing entries, I won't announce details. Only announce the summary route entries with the same characteristics. And after summarization, we find that on R1 side, we can immediately route any specific destination address according to this summary route. Then, on the router, suppose there is such a setting now, we now have both devices' automatic summarization completely turned off. We do this. Then on R1's router, we create several more IPv4 addresses. For example, R1 here has 1.100.1.0.1, 24 IPv4 address, 100.1, 1.1-24, 2.1, and 3.1 IPv4 addresses. These 4 IPv4 addresses will all generate corresponding direct routes, 100.1, 0.0-24, 100.1, 1.0-24, 100.1, 2.0-24, 100.1. 3.0-24, will generate these 4 detailed routes. We declare them all into eigrp, passing them to our R2 and R3. So doing this on R1, interface loopback 100, IP address 100.1, 0.1-24, loopback 101, IP address 100.1, 1.1-24, loopback 102, IP address, loopback 102, IP address 100.1, 2.1-24, loopback 103, IP address 100.1, 3.1-24, we run eigrp on all these 4 addresses, router 1990, network 100.1, 1.1, We still use the loop announcement, forgot about 100.1.0.1, 100.1.2.1, and 100.1.3.1 run eigrp. So at this moment, for R2, we can receive from R1's announcement the detailed routes 100.1.0.0, 0.0, 1.0.2.0.3.0, these 4 detailed routes. Now let's run manual summarization. On R1, we hope when we announce these detailed routes to only announce the summary route and eliminate these 4 detailed routes, turning them into a summary. So in this case, only the summary route is announced, transforming into a summarized form. So let's say we do this now, finding the commonalities among these 4 detailed routes, finding their common prefix, and the common network bits. 100.1. We write it like this: 0000001.0000001.0000001, 0000001, 0000001. I write the route. Also 1001, 000000010, 00000000100.1. So these 4 detailed routes, we just mentioned the rule. What's common is retained as it is, different turns to 0. This way it's determined he can find their common prefix. What's common is retained as it is, different turns to 0. NA's pivot point, right? Everything is the same at the front, different turns to 0 at the back. Their common network bits are these bit positions that are the same. That is to say, what we should summarize is 100.1.0.0 with the first 22 bits being the same. Network bit, just 22, finding all these detailed, hot, common prefixes, and network bits. Then we aggregate. Our summary should be 1, so 100.1.0.0 minus 22 summary route entry to our R2. So here, write down on R1's side how to do manual summarization. Students must pay attention at the interface. In summarization, in our distance vector routing protocol, we definitely do it at the interface, because the distance vector routing protocol is when we announce. From the interface announcement out, the detailed routes, we do summarization for him when announcing out, do summarization using the command line IP, summary address, then specify, of course, now we don't allow RIP, we specify eigrp for eigrp 90, eigrp process number 90, in such a process of route entries. When I want to announce from interface 0, I give him a summary. Summary address summarized into what? You can write it out, prefix plus the same network number. You can directly write in what format? 100.1, 0.0-22, You can write it like this, but I suggest students should still write in mask format, because we are network engineers, we should practice a bit more. This technique of writing a mask, how much is the mask? Minus 22, right? 255, 255, 252, 0 students. We summarize into a 100.1.0.0, 22 root. We tell it to 2 reals. Then we have to wait a bit. He will say, our summary configuration is good. We need to resynchronize. We will send an update packet. Then on the 2 reel side, there is an IP route. Then finally, we can only see 1. You see 4 and 1, right? Turned into a 100.1.0.0, 22 summary route entry. Next hop is 172.16.12.1, comma, students. 1 reel announced the detailed routes and then summarized. This is our basic summary configuration, manual summarization. Under the interface, manual summarization. Under the interface, utilizing an IP summary address. Summary is configured under the interface. When advertising route entries through eigrp while advertising detailed routes, perform summarization. This is manual summarization. Let's examine the characteristics of our summarization. Firstly, it suppresses detailed routes, only announcing summary route entries. Clearly, on the R router, you can't see those detailed routes anymore. The first characteristic of summarization is very clear. Second characteristic, let's look at the routing table in R1 at this moment. There will appear a special route entry, 100.1.0.0i, 22. Our summarized 100.1.0.0, 22 route entry. Who is the next hop? Called the null zero interface. This null zero interface is present on every router, known as the void interface, or called the discard interface. Called the discard interface, or trash interface, you can call it whatever. So null zero, you can think of it as a trash bin. For R1, I take these detailed routes and summarize them into 100.1. 0.0-2, 2, comma, after summarization. I specifically create in the routing table a route to such a destination IP subnet. I directly throw the packet to whom? To null zero. Throw it to a trash interface. Why do we do this? Students, why? We need to deal with such a situation, students. Why? We encounter this situation, our destination address data, we actually need to discard it. We summarize into such a routing condition if we discard it. Why, students? It's actually in this situation, students. So let's say when I summarize a rather large range we just mentioned, can directly summarize these detailed routes, their common characteristics, find a very precise summary route, 100.1.0.0, 22 a very precise match for these 4 detailed routes, summary route. And we also mentioned summarization can be adjusted by yourself. For example, on R1, I don't want to summarize into -22 routes. What do I summarize? Interface 0. 0 then, IP note drop IP summary address, 100.1.0.0, eigrp 9100.1.0.02, 5.25.252.0 such, a summary route. I don't want to summarize anymore. I change it right. I find a not very precise summary of such a network segment. For example, I summarize these 4 detailed routes all into what? 100.1.0.0. 16, can I? Of course you can. We mentioned manual summarization just now through such a prefix matching method, found a very precise match to these 4 detailed routes. A very precise same prefix, same network number, like same network position. Is it the same mask? So when we manually configure, of course, we can also match a not very precise, a larger range of such a space summarized. Of course, we can summarize what? Of course, we can summarize 100.1. 0.0/16. That's right, 100.1. 0.0/16. The first 16 bits are network bits. These are also from our 4 detailed routes. They have the same characteristics, which can also be summarized. Folks, the range is up to you. You can summarize smaller or you can summarize larger. Suppose I summarize larger. This is how I do it. IP summary address, eigrp 9100.0.0.0. I summarized it to 25.25, 0.0/16 as a mask route entry. Is that possible? Of course it is. The range of manual summarization is up to you. If summarized into such a route entry for R2, then I have such a route, 100.1, 0.0/16. Next hop address is R1. Okay folks, after summarization, R1's routing table will contain a 100.1, 0.0/16, pointing to null 0, which is the trash bin, meaning any access to 100.0. 0/16, this destination address of the website gets thrown away into the trash bin. It's a loop prevention route. So this loop prevention route, what happens if it isn't there? Folks, let's assume if we didn't generate such a loop prevention route, and just as you guys know in R1's routing table, we have such a route 0.0.0.0, a default route pointing to R2, what problem could arise? Folks, what could be the problem? For example, R2, we access 100.1.0.1. Is that possible, accessing 100.1.0.1? According to this, summarized. This summarized forwarding, going to such a destination address, all data gets thrown to R1, R. 1 has such a detailed route, 100.1. In R1's routing table, still a detailed route, just summarized when advertised. In R1's routing table, direct connection route, 100.1.0.1, still thrown to our white route. 100 can connect access 100.1.0.2 can also be forwarded, according to this summary. Thrown to whom? Thrown to R1, 100, 1.0. Sorry, 1.1 can also be thrown to our R1 thrown to route white 101 interface can connect. But if at this time IR2 access 1, R1 does not actually exist. A detailed route's IP address. For example, I go to access 100.1. 100.1 I access such a destination address. Is there a route for R2? There is a route. How does this route come? It comes from R1's larger manually summarized route entry. Then who gets the data packet? Thrown to R1. Then on R1, we need to find a route. 100.1.1.1. This destination address. Is there a route? Turns out R2 is accessing R1, a non-existent IP address. There are no detailed route destination IP addresses. What if there is no route? There's a default route. Where does it go? It goes to R2R1. Look at the destination address. 100.1.1.100.1 goes to R2 via the default route. What does R2 do then? The destination address 100.1.1.0.1. Who's the next hop? Summarized just now, the 16-page route. The entry can certainly match. Go to R1R1 to R2R2, back to R1. Now a loop occurs. Folks, a routing loop has occurred. Folks, because the summarization range might be quite large. And the other party just defaults the route over. That's how the loop happens. So what do we do? If when we summarize, the router could automatically generate a loop prevention route. For instance, R1 does the summarization. Then it automatically creates what? UAccess is 100.1. 0.0/16A loop prevention route for such a network segment, pointing to null 0, pointing to the garbage heap. Then suppose it's still the same old way at R1. We access 100.1.0.1. Detailed route. Summarized route goes to R1, packet thrown to R1. 1 takes a look. The destination address. You want to access 100.1.0.1. Destination address, summarized route, can match. Default route, can match. Detailed route, can match. We've said. If a destination address can be matched by multiple routes simultaneously. We NA have talked about if a destination address can match multiple routes. Then, based on the longest match principle, find the route entry with the longest mask for forwarding. Right, folks. So, the same destination address, 100.1.0.1, has this default route, has a summarized generated loop prevention route, but has a detailed route, 100.1, 0.0/24. We go by the detailed route, thrown to loopback 100. Can connect, folks. It can connect. Then, if I access one non-existent address, such as 100.1, 100.1 has one summarized route going to whom? Thrown to R1. Then, if R1 previously had no summarized loop prevention route, without it. Then there's no detailed route. What do? Go by the default route thrown to R2, looping. Now, when we've generated a loop prevention route, I look at the destination address, 100.1.100.1. Are there any detailed routes? No detailed routes. But what is there? There is one 100.1.0.0. We can be matched by the default route, can be matched by this summarized generated loop prevention route, from where destination IP address can match up two routes. Go with the longer mask, based on the longest match, principal route with a longer mask. Don't go by the default route. Go detailed. Go who? Go to null, 0, accessing 100.1.100.1, no detailed route. What is there? There's loop prevention thrown to whom? Thrown to a null 0 port directly discarded. Folks, you see, R2 accesses a non-existent address. If we have a default route, R2 just loops back. So if there's a loop prevention route, we just discard it directly, thus avoiding routing loop issues. Folks, this is why loop prevention. After we summarize, we automatically generate such a loop prevention route, inserted into our router's routing table. It's to prevent these kinds of troublesome situations from happening. To prevent. For example, you see our default route commands. This won't cause looping darn undo with Ctrl plus Z. How did everything get undone at once? Then the issue of loop prevention. Any summarization, folks, whether it's automatic summarization or manual summarization, they all generate such a loop prevention route. So let's make a note of it. Summarization. First, characteristic, suppress, detailed routes. Only announce summarized routes. Second characteristic, summarization will automatically generate automatically. In the routing table, it will automatically generate loop prevention route to prevent loops pointing to null 0, which is the junk interface called the discard interface. Either way is fine. Junk interface, discard interface, whatever you call it, discard interface. So we can also say it's a null interface. However you want to call it, the main function is to prevent loops. Folks, this is the second characteristic. Now the third characteristic, now we manually summarize, folks. What you need to pay attention to is the ranges not covered by the summarized route. For example, we have one we want to summarize into a route entry of 100.1 0.0/22. Then we summarize into a 00 interface node, IP summary address, eigrp 90,100.1, 0.025.25.0.0. Remove this summarized route. We re-summarize to the original eigrp 9100.1.0.025.25.252.0, summarized into a more accurate route that can match these four routes. Summarized at route now, folks. On R2's sideshow IP router, what we can see is 100.1.0.0.a 22 summarized route. So what you need to pay attention to is only detailed routes, only summarized routes, including detailed routes, can be summarized. It's very simple, folks. Just a simple statement. Like, now on a device, I create another 100.1, 5.0/24. Now here comes the difference, 100.1, 0.0/22. The difference is here 100.1, 0.0/2 to 100. 1.000.000.000/22. So if in our routing table there appears a detailed route, 1.0.0.1.0.0.1.0.0.1, it's not 101. Is there a 0 missing above? Not missing. It seems not aligned. 101.0.0.0.0.0.0.0, then you haven't been included in our summarized route, included therein. Our network bit is not consistent. You are 100.1.0.0.0.0.0. We are 100.1.0.0.0.0.1. Our network bits are inconsistent here. They are not matched by our summarized route. We will not participate in the summarization. For instance, here at R1 interface loopback 5 IP address 100.1.5.1. 25.25.25.0. We let it run our eigrp. Thus, this detailed route is not included in our summarized route. It will not participate in summarization. In our R1 routing table, it will not appear. You can see this 100, 5.0. This detailed route, because it hasn't been included. Folks, this is a point. So the routes not included in the summarized detail will not be summarized. Now the fourth point. When we summarize, as long as there is at least one detailed route, summarization can be established. For example, on R1, we aggregate 1.0.0.0.01.0, 2.0, 3.0 detailed routes into 100.1. 0.0/22. This summarized route, as long as it exists or whatever, as long as there is one detailed route, it can be summarized. For instance, on R1. Now I do this. Now I disconnect, right? I now summarize these 4 detailed routes into one summarized route. So if one detailed route is lost, like interface loopback 103, shut down, I disconnected one detailed route. No problem, show IP eigrp in your database. There is no more 100.1.3.0 detailed route. Only 0.05, 1.0. Then we still have 2.03.0, right? 100.1.0.0, 2.0. No more 3.0. But our summarization still takes effect. The summarization still holds. You see the loop prevention route is still there. Then our interface's detailed route. Our direct routes are still there when summarized out. You see, we can still generate this, can still receive this summarized route 100.0.0.0, 2, as long as there is one detailed route. For instance, if I now take down our loopback, then 101 to 102 also down now in our detailed route. Only this one detailed route exists. Then our summarization can still hold as long as there is one detailed route. Our summarization can be established. You see on R2's side, we can still see 100.1.0.0, 22 summarized route. So as long as there is at least one detailed route establishment counts. So if I now remove our last detailed route, 2 detailed route, gone 2, folks, you must grasp the concept of summarization is when I announce the route entry here, summarize these 4 detailed routes into one summarized announcement. So if there is not even one detailed route, what summarized route do I announce? Folks, do you understand? Not even one detailed route, then summarization will fail. Like when interface loopback 100 is down, now the only detailed route is also gone, then show IP route. You see no 100, 0.0-22 anymore. Summarization has failed. Folks, so the 4th condition. Folks, take a look, okay? Folks, something to note, folks. So, summarization applies to any route advertised from one's own database. Route can be summarized. Manual summarization targets routes we advertise ourselves, not those we've imported into our database. The effectiveness of advertised route entries. Automatic summarization only applies to routes originated by ourselves. Effective folks, automatic summarization must apply to route entries. I announce only then can I summarize it into a major class for announcement. For my school's route entries, for example R2, if it pertains to what we've learned. The summary route, entry 100.1.0.0. 22, I use automatic summarization. I am unable to include this 100.1.5.0.22, this route. This detailed -24 route on R2 when I enable automatic summarization. It can't apply to the routes we've learned. Route entry to be summarized. Folks, automatic. Summarization can only target routes. I personally declare, entering into the database from my own device. When I announce my detailed routes, then I can automatically summarize into a major class. Look here at R3. We still see the 100.1.5.0 detailed route. We just blocked that path. Loopback 100 to 103, no shutdown. You can still see the detailed route. Clearly, for R2, we lend out the major class 192.168.23.0, announcing the detailed route, major class 100.0. 0.0/8, different, should be summarized into major class announcements. But R2 does not automatically summarize because automatic summarization can only target our own originations. When we send our own route entries, then it can automatically summarize. Manual summarization can target routes advertised from our database. Even routes we've learned, I can also summarize them. For example, R2. Now, after enabling automatic summarization, we did not convert this one 00.1.5.0100.1. 0.0/22 route entry into a major class route. You see, it's still a detailed route. Now I do this. When announcing from R2 to R3, I summarize these learned route entries. So I just summarize it as 100.1.0.0 anyway, 100.1, 0.0/16 route entry. If we manually summarize it, can simultaneously target our own originated routes, and the routes we've learned both can be effective eigrp 9100.1, 0.0/25.25. 0.0, it's still detailed. Now let's see if it works. Show IP route. Good, 100.1.0.0. You see the /16, folks. This is our manual summarization and the difference from our automatic summarization. So later you can also say, automatic summarization only applies to our own originated routes effectively, while manual summarization can be effective everywhere. That's the concept of summarization, folks. Any questions? Any questions to raise? R2 can summarize R1's detailed routes. Can it also summarize R1's summarized routes? Yes, exactly. That's just what we did. Just now on R2, we've already received the summarized route from R1100.1.0.0, 22, and another 100.1.5.0. 24. You see, we still summarized it. The summarized routes we received. We can also summarize, look, it's summarized into 100.1, 0.0/16. All summarized, is that okay, folks? Any more questions? Any question? No more questions? Folks, any questions about summarization? Any questions, folks? 8:01, no more questions. If there are no questions, let's take a break. Let's rest a bit. There's a lot of valuable information. Take some notes. You might want to jot down some notes. Take notes. Jot down your notes. Then we'll take a 15-minute break. We'll be back at 8:16, 8:17, 8:17. We'll continue the class. Then, has anyone not submitted their notes? No, I did them. Didn't I submit? What the heck? I'll check I did them. Let me see, I should have done them. I did them in Markdown. Done metric calculation mechanisms, didn't do them. I didn't lose them. I'll check. Did I throw out last class's notes? I really didn't throw them out. Then it's fine. Sorry, I forgot, really didn't throw them out. Offset lists and more. This was the last thing. Uploaded the video. Didn't upload the notes. I'll drop them for you. Get more up there. Change the prefix eigrp topic. It's up. You can refresh to see. Forgot. Sorry. Forget the text video. I guess I don't need to count this. Okay, let's take a break. We'll be back at 8:17, 8:18. Wait for me to continue.